Hi guys, this is the help video for Unit 2 Assignment 6 in Schoology. And this video, or this assignment, is all about the Pythagorean Theorem. So here's just a quick review of the Pythagorean Theorem. The formula says a squared plus b squared equals c squared. And the important thing to remember here is c is always the hypotenuse, which means when you start a problem, you need to find the right angle. That was going to be purple. You need to find the right angle and then go directly across from it to locate the hypotenuse or to locate which one is C. It doesn't matter what order you put A or B in. I usually always put them in least to greatest unless they're labeled like A equals something and B equals something. Okay, and what this actually says, A squared actually means the area of the square off side A. And b squared actually means the area of the square off side B, and then c squared means the area of the square off side C. And if you took the blue and the green square and you tried to fit them into the red square, if you kind of, cut them up a little bit or whatever, it would fit in there perfectly. These two squares added together is exactly equal to this square. So when we solve them, sometimes it'll ask for the area of the square. So like if you get down to a problem that says c squared equals 100, that's the area of the whole square. C squared is 100. But if you wanted just the side length of c, then you would have to finish and get down to c equals something. And to get rid of the square, the opposite of squaring is square rooting. Squares and square roots cancel, and you have to do it to both sides. So sometimes your answer will be like c squared equals something if they want to know the area of the whole square. And sometimes your answer will be just c equals something if they just want to know the side of c. So I want you to know the difference between like the square and the regular letter. Okay, so let's try this first one. We want to solve for x. All right, so in every single equation, the job is always to get the x by itself. Right now there's a square, and we need to get rid of the square. Just like everything else in equations, you do inverse operations or opposites. If you're adding, you subtract because those are opposites. If you're multiplying, you divide because those are opposites. If you're squaring, you will always square root because squares and square roots are opposites, so they cancel, leaving you with just x. And whatever you do to one side, you have to do to the other. The square root of 121, it's actually positive 11 and negative 11. Because we're asking ourselves what number times what number equals 121. Geez, I'm having issues. And it has to be the same number times the same number. So 11 times 11 equals 121, but also negative 11 times negative 11 also equals positive 121. So in this case, since we're taking the square root, it could be a positive 11 or it could be a negative 11. Either one of those answers would work. Now, when we get to like actual triangles and we're looking at side lengths, you can't have a negative side length. So sometimes you won't keep the negative answer. Sometimes you'll just keep the positive. Okay, so this is a little bit of a matching game. I forgot to make my pieces movable, so they're not going to move for me. But we're just trying to plug them into the Pythagorean theorem. And remember, the Pythagorean theorem says a squared plus b squared equals c squared. So we got to get them in the right spot. So if we look at this first one, we don't know a, b is 12, and c is 13. So we're looking for one that says a squared plus 12 squared equals 13 squared, which is right here. All right. If we look at this one, a is 5, b is 12, and c we don't know. So we're looking for the one that says 5 squared. I'm just going to write it down here. 5 squared plus 12 squared, excuse me, equals c squared. And so that is the second one. Down here we have a is 3, so a squared plus we don't know b, so b squared equals c squared, which is 5 squared. So that looks like this one. And then the last one, a is 3, so 3 squared, b is 4, so 4 squared equals we don't know squared, or c squared. So that's the first one. All right, what is the approximate length of side C? Now, a lot of times when you look at a graph, you can count the spaces. What I mean, like if you look at side B down here, Notice how it lines up perfectly with the grid spaces, so we could just count 1, 2, 3, 4, 5. B is 5. All right. We could also look at side A, and it follows the grid perfectly. So we could also count side A. 1, 2, 3, 4, 5, 6, 7. But when we go over here to try to count side C, that's like a little over 1. That's a teeny tiny piece. This is like 3/4. There's no way that we can really successfully count this because it doesn't follow the grids from the graph. So since we can't just count the spaces because they're not lined up, we're going to use Pythagorean Theorem. So we're going to plug it in. A squared plus B squared equals C squared. And then we have some solving. 7 squared plus 5 squared. Y'all, you can do this in your calculator. If you're using Desmos, you can type it in all in one step. Let me show you that. So if you do 7 squared plus 5 squared, it'll tell you that that's 74. If you wanted to do them separately, you could do 7 squared, write down 49, and then you could do 5 squared and write down 25, and then you could add 49 plus 25. It's just a lot more clicks. So when I do it in Desmos, I like to type it all in one step. So 7 squared plus 5 squared all in one step, okay? And then I write down 74. So this whole side here, wait, why is it not writing? This whole side here equals 74. So C squared equals 74. That means that the square off side C, the area of that square is 74 units. But this problem does not say what is the area of the square. This problem says what is the length of C. So we're not done yet. We need to go ahead and get C by itself. Since we're squaring, the opposite is to square root. Squares and square roots cancel. And then the square root of 74, that's not a perfect square, so we just need to get an approximate answer. So we type in the square root of 74, and it's about 8.6. So you could leave your answer a couple different ways. You could leave it as square root of 74. Oops. You could leave it as approximately 8.6. It just depends on how it's written in a multiple choice option. All right. The segment lengths 8, 12, and 15, do they form a right triangle? I think it's supposed to say do. So the only way to check to see, it's a true or false. I can't even read. The only way to check to see if they form a right triangle is to use the Pythagorean Theorem. If the Pythagorean Theorem is true, then yes, it's a right triangle. I'm just going to put that symbol. If you solve it and it's false, it's not true, then it's not a right triangle. So let's look at and see what I mean by that. I like to plug them in least to greatest. So I would say 8 squared plus 12 squared equals 15 squared. And now I'm going to solve this side of my calculator. 8 squared plus 12 squared. 8 squared plus 12 squared, 208. Okay, I'm going to go ahead and write this side down, 208. And now I'm going to do 15 squared in my calculator. 15 squared is 225. And this is not a true statement. 208 does not equal 225. So these do not form a right triangle because the statement is false. 208 does not equal 225. So that would be no, they don't form a right triangle. For the rectangle shown to the right, which equation could be used to find the value of x? Okay, so we're given a rectangle, and you might think, well, wait, I can only use Pythagorean theorem on a right triangle? But if you look at this, if you just broke this piece off, this piece is actually a right triangle just by itself. So we don't need the whole rectangle. We're just looking at the right triangle. The side across from the 90-degree angle always has to be C. And the other sides I just plug in least to greatest. So 5 squared plus 11 squared equals C squared, or you could leave it as x squared, it doesn't matter. And then you're going to take 5 squared plus 11 squared and type it in your calculator. That's 146. So 146, I'm going to go ahead and do all this at once. And then I'm going to take the square root of 146, and it's about 12.08. Now I'll show you why I did all that. So So first I added up, I solved these, got 146 equals c squared. But remember, we don't want the area of the square, we just want the side length. So we have to square root it to get c by itself. So c is approximately 12.08. Or yeah, that's right. Okay. A firefighter places a 50-foot ladder 20 feet from the base of the building. What is the closest to the height it will reach on the building? So we have a building, and then we have a 50-foot long ladder. Excuse my drawing, I am not an artist. So this is 50 feet long, and we know that it's 20 feet, from the base of the building. Well, the building has to meet the ground at a 90-degree angle. It just has to. You can't have well, actually the Leaning Tower of Pisa doesn't, but everything else does. So we form a right triangle. Even though it never says that we have a right triangle or to do the Pythagorean theorem, you have to draw it out and then figure that out. Like you have to see what shape it is. So remember, the side across from the 90-degree angle is always side C. And we don't know this side. We can just call it X or A or whatever you want to call it. And then we're going to plug it in. X squared plus 20 squared equals 50 squared. We can go ahead and do these in our calculator. 20 squared should be 400. And then 50 squared is 2,500. So let me write those down. X squared plus 400 equals 2,500. Now remember, our goal is to get x by itself. So we need to get rid of plus 400. The opposite of adding is subtracting. So we're going to subtract 400 from each side. Bring down our x squared. We don't want to know the area of the square. We want to know the length of the side. So we got to get rid of the square. And the opposite of squaring is square rooting. So we're going to square root both sides. And you might know this already in your head, or you can type it in your calculator. Square root. Actually, that's going to be an ugly decimal. Nobody knows that in their head. It's 45.8. So our approximate length is about 46 feet. So we're just going to say approximately 46 feet. All right, let's look at the next one. Find the perimeter of the rectangle in the diagram. So if we want to find the perimeter of a rectangle, remember, perimeter means you're adding up all the sides. And then we know, since it's a rectangle, opposite sides are the same. So if this side length is 3, we know this side length is 3. But we don't know the value of the top or the bottom, so we have to figure that out. And the way we do that is we have a right triangle. I'm going to write it over here. Oops, that's a terrible picture. So we have this right triangle with these values, and we need to solve for this missing side. All right, C is always across from the hypotenuse. Always across from the 90-degree angle. It's always a hypotenuse. So we have x squared plus 3 squared equals 5 squared. 3 squared is 9, 5 squared is 25. Trying to get x by itself, so we subtract 9 from each side. That will equal, what is that, 16? And then we don't want the area of the square, we want the actual side length. So we got to get rid of the square by square rooting. Now when you take the square root of 16, it's a positive and a negative 4. But since it's a side length, it only makes sense for it to be positive. It doesn't make sense to have a negative side length. But now that we know this side's 4, we know this side is also 4. So to find the perimeter, we add up all the sides. So 3 plus 4 plus 3 plus 4, let's see, that's 7, 10, 14. So our perimeter is 14 units long. Y'all, I think I'm actually going to have to split this into 2 videos. So I'm going to stop the video right here, and we're going to pick up on the next video.